We are team 811 from Vishwakarma Institute of Technology, Pune, and this complete thing is our project for Texas Instruments Analog Design Contest 2013 India. Our project name is Hobbiteye, and it basically is a spy robot. And this, what we have made here is a robot which will assist armed forces or military forces to gather intelligent data about enemy location, so that they can manage or they can strategize their move accordingly. What our bot does is it takes audio and video feeds from any given location and then transmits it wirelessly to a different location, so that it can be used effectively to make a appropriate strategy against the enemy. So I'll just quickly go through all the components we have used here. This is our wireless camera which we are using to transmit audio and video feeds from a location, and it runs on a 9-volt supply, 9-volt DC supply. This is a radio receiver, wireless camera receiver. These are the audio video outputs of this, audio and video output of the camera. This is a TV tuner card, so that we can connect directly this to a USB port of a computer, so that all the feeds taken from any location can directly be seen on a laptop screen. Okay, now this is a switch box which will be held by a personnel or the armed forces, so that he can control the motion of the bot. We are currently using only 4 of these, but we can increase the number of switches as per our application. Currently we are using only 4 for the direction controller for motors. All the input from here, input from these switch boxes is taken and is given to our microcontroller. We have used the MSP 430 EKP microcontroller, and yes, and then according to the data received from the switch box, there is an appropriate signal generated, and it is transferred to this ZigBee module through UART protocol. This is a ZigBee module. It runs on a 5-volt supply. To create a 5-volt supply, we have used a 7805 IC. We can connect any general battery about 10 volt here, so that we can get a 5-volt supply to DC, 5-volt DC supply to the ZigBee module. This is our ZigBee transmitter. Then this is the robot side. This is our ZigBee receiver. The data which is sent through this ZigBee is wirelessly transmitted onto this ZigBee, and then the data which is received on this ZigBee is transferred from this ZigBee to again an MSP 430 launchpad, again to a UART module. Then whatever data is received, it is appropriately processed through this microcontroller, and appropriate control signals are sent to the robot. These control signals will help for locomotion of the robot. Then we have used, as we all know, that this microcontroller runs on a 3.3 volt supply. So for making a 3.3 volt supply, we have used a regulator IC which is LM1084, which creates a 3.3 volt regulated supply which will run our microcontroller. Now this is the main robot. We have used 4 DC motors over here. This is our complete bot chassis. This is a 12 volt lithium ion battery which will run the motors. This circuit here shown here is a motor driver circuit. This IC, as you can see here, is DRV8432 edge bridge motor driver. We are actually controlling our 4 motors using this motor driver. We have also used an isolator here. This isolator is ISO 7402, which again isolates the supply and the control signal and the power signal. Okay, so now we will see the actual field testing of our robot. So this is our actual robot. Here, this is our ZigBee receiver. This is our MSP microcontroller, and this is our wireless camera. That's it on the bot, and the battery is as usual. And on the controlling side, this is again an MSP microcontroller. This is a ZigBee transmitter. The battery is as usual. This is the controlling switch, and this is the wireless camera receiver. And as you can see on the laptop, we can see the live feeds, live audio and video feed from the wireless camera on the robot onto the screen of the laptop. So now run it. So as you can see, the bot is being controlled wirelessly. The bot is being controlled wirelessly. Now you can clearly see that it's out of the line of sight of the operator, and still it can be very efficiently controlled. And all the while it's also continuously transmitting audio and video feeds, which not only helps the controller to control it, but also provides strategic locations of the enemy, which can be vital for strategic planning. So it can be clearly seen that it is very efficiently controlled wirelessly, and at the same time it's also transmitting audio and video feeds continuously to the laptop screen. Here is the feed.